Welcome to Agile Clips, where we break down Agile into manageable pieces. In this episode, we speak with Dr. David A. Bishop about the role of Agile methods in the development of complex systems comprising hardware, firmware, and software. Often, these systems are developed using a hybrid methodology, with some teams using Agile and others using waterfall techniques. Hi, everyone. Today, we're fortunate to have a guest speaker, David Bishop, and I will ask David right now to introduce himself.
Hi, well, my name is David Bishop, and I am a Agile consultant and business researcher. I'm a researcher with the Center of Engaged Business Research at Georgia State University here in Atlanta. I've also been in the technology business for about 25 years. I worked for a variety of companies in the technology space in a variety of different verticals, including everything from web to e-commerce to IoT to blockchain to IVRs and pretty much everything in between, a little bit of everything.
Great. So prior to starting the recording, we had spoken about some topics that we wanted to cover. And I know the first one was about how can Agile be adopted to embedded systems development. So maybe we should start with your definition and examples of embedded systems.
Sure. Well, you know, the interesting thing about technology development today is that it's not just about software anymore. It's about devices. You know, 15, 20 years ago, all the innovation was mostly happening in the software space with e-commerce and things like that. But today, it's all about smart devices. Whether it's your smartphone or whether it's smart meters or smart cars or any type of device. And that's where all the innovation is happening today. That's where all the cool stuff is going on, if you will. And those are essentially embedded systems. And what an embedded system is a product that has hardware, firmware, and software combined. So this hardware, firmware, and software is often developed on separate tracks by separate teams, but at some point it has to be tested and released as one cohesive product. And that's challenging to do with Agile. Many companies who develop embedded systems-based products have the most difficult time adopting Agile.
Yeah, so actually I can think of a prime example, but if I mention it by name, she will answer back and say she didn't understand what I was asking. So I think, Santosh, you were going to say something?
One of the things that you just mentioned earlier is that if there are three different tracks being developed, where do you see the maximum contention or integration, or where do you see the challenges?
Well, the challenges are often trying to figure out how to adopt Agile for all the different tracks. Many times when an organization like that takes on an Agile transformation initiative, they try to have all these different development tracks, all these different teams assimilate Agile the same way. And that really doesn't go very well. Our case studies show that you have to adapt Agile differently based on the different tracks. The other challenge is testing, right? So it's all these different tracks are essentially three different products, and they're tested individually and they're tested by separate teams. But at some point, they have to be tested as a system. And sometimes there's conflicts with, okay, this team is ready and this team is not, or we don't have the correct hardware, or we don't have the correct rev of firmware, and all of these different tracks have interdependencies on each other. So that tap dance of coordinating the availability of all the different releases of all three tracks or components and testing those together and making sure it all works right and getting it released as one cohesive product is difficult in itself.
So I'm assuming you have maybe a way or recommendation by which these embedded systems can actually adopt Agile.
Right. Yeah, absolutely. That was over 10 years ago when I started getting into this, trying to solve this Agile problem. I saw this problem firsthand with some of the companies I worked with. Mm-hmm. It was it's not easy for every company or most companies, but it was much easier for software-only companies and organizations to adopt Agile. but companies who were developing these kinds of products were having a very tough time. And I thought, I want to try and crack the code on that problem. And so I set about a 10-year research study on doing just that. And that's what the book MetaGility and came out of, and also the research studies that MetaGility is based on. And what it essentially is it's a hybrid form of Agile, where you have, for example, you have your software teams may have a pure adoption of Agile, where they may have 2-week sprints, they may have their daily stand-ups, they may do all the typical Agile things. But your firmware teams may move a little bit slower. They may have 30-day sprints. They may not have stand-ups every day. And then you have your hardware teams, which may move somewhat slower because the hardware doesn't change as often as the firmware, and the firmware doesn't change as often as the software in most cases. And so the hardware teams may have more of a closer to a stage gate type of development process, but they also use rapid prototyping and other techniques to keep up with the other faster moving tracks as well. So they have their own brand of agility that's not the same, but they have ways of keeping up. And of course, there's a whole series of meetings and interactions that go on between these tracks that I document in the book on how to manage this tap dance, if you will.
So it's like firmware folks need to almost like be in sync with the software folks so that they can synchronize it.
Yeah, absolutely. Because a lot of times the software teams may need the latest release of the firmware to test against or to develop against. And the same thing with the hardware. So it's kind of a chain reaction. The firmware guys are going to need the hardware, and the software guys are going to need the firmware and the hardware to do their testing and development as well.
So is there a role for Kanban in this mix? Because everything you mentioned sounded like it was on regular time intervals or cadence like Scrum.
Yeah, absolutely. I think Kanban is a very good methodology for managing your work in progress, and having those cumulative flow diagrams where you can sort of visualize your work in progress at each stage of development and trying to figure out where those bottlenecks are. I think it's a very good approach. Although with embedded systems development, you're going to have some pretty complex cumulative flow diagrams and Kanban boards, but that is such as it is. There's ways to manage that.
Mm-hmm. Yeah. So from coordination point of view, I'm assuming you are also thinking something similar to like a program board kind of thing, where you see every team doing what across different sprints and releases type of thing?
Yeah, actually, that's very true. So a Kanban board is one part of it, but in this type of context, it's not the only thing you have to have. You've got to have that project view and that program view across all teams. That's very important.
So can you give us some example of where you had these type of things come together, where it actually worked better for everyone?
Yeah, so I would say, like, for example, with Toshiba and Nokia and Intel have done some variations on this approach, especially in the smart metering space. And so that has allowed them, in the smart metering case study, I would say, allowed them to become number one in their market. It helped them get more meters on the ground than any of their competitors. And that's an important perspective on Agile. When people talk about Agile transformation, people aren't always sure why they're doing it. Are we doing it to be more efficient? Are we doing it to make our teams happier? Are we doing it to create more synergies with other teams? But in reality, the core reason for Agile, or the original reason for it, which is why, based on lean techniques and all that stuff, is to become number one in your market, or to be market competitive, to try and get innovative solutions out to market as quickly as possible with the highest possible quality and customer satisfaction. That's really what it's all about.
Yeah, it's finally coming down to what the customer sees and how frequently you can get to them as quickly as we can. They don't really care behind the scene what goes on.
Right.
Yeah. I mean, we see that in multiple places, not just only at the embedded systems level, but even at hardware type of where we had seen this, that the customers who really wanted a good and quality product in the regular time frame. and the first one gets to the market wins.
Right.
Ah,
And when the embedded systems, that's it's hard to do, not just because of the context of the complexity of the product and the teams, but also most embedded systems have higher quality constraints. They have safety constraints. A lot of embedded systems may be, a control unit in a self-driving car or an avionics system in a jet fighter. So these things can't fail. It's not like an e-commerce website where,
right.
okay, if it's down, it's not a big deal. You don't want these embedded systems to go down because they're they have to be very, very fault tolerant and have to have much higher quality expectations.
Right. Yeah. Yeah. And the failure is a bigger impact than e-commerce.
Absolutely. People can die, and that's
true.
And we saw that with like the Boeing, the 737 Max. That's. And I think we're seeing more and more of that. 15, 20 years ago, if you had a technology failure, it was an inconvenience, or a company may lose some money. But today, people could die, as we saw with the Boeing situation, or it can have super negative impacts on our financial systems and our economy because of the situations we've seen at Equifax and Capital One.
That's true.
So as software in general and technology in general becomes more embedded in our lives, it's going to have a greater and greater impact. And I think we're going to see, a greater outcry, if you will, for higher quality than I think we used to in the past.
That's interesting because I think the idea behind Agile or any of these things was that we deliver the quality product consistently. And now just the bar is getting raised higher and higher with the IoT and those kind of things, where even little bit of things constantly go into your day-to-day life.
Right.
I mean, I'm just thinking now that everybody's working from home. It's like if the internet goes down, your life stops.
That's true.
I mean, it just that last mile of reliability has to be 100% there.
Right.
So I would like to change the subject slightly and talk about planning in this kind of environment, because at least in my experience, you can almost have, let's say there are three aspects or three components to the total solution here. It can be, each team in some sense could be using any methodology. It could be Agile, it could be waterfall, but the key is really to align on certain milestones, I would say, and to make sure those milestones are met and to have good communication and so on. And the part that I found to be important, at least in my experience, is to make sure that these milestones are as close together as possible. Not stretched out by months, but being on a shorter time period, and aligned in such a way that you can do end-to-end testing of at least one feature as you go along. So you don't want the different components to come together late in the cycle for the first time. You want to really show a very thin thread of functionality that's end-to-end involving all three components, and then you keep building on that. At least that's my experience. I'm wondering if that's what you've also found, and that makes sense.
Yeah, I would say that most of our case studies, when I talk about this hybrid form of agility, what they did is you may have these three different development tracks, hardware, firmware, and software, that adopt Agile differently. But they used stage gating as a way to keep all three of them in check. And you could say, well, those are stage gates or milestones, whatever you may want to call them. But that's essentially what they're doing, is the stage gating was used as sort of a check and balance against the Agile process to help keep all these different tracks in sync.
So if we get this that goes from end to end through all the three systems, can we talk to each other? Are we able to get to the basic components running and then start adding more things to it? Is that something that you see in the embedded systems also?
I would say to some extent, yes. Generally it starts with with any kind of a cross-team, cross-track development. We'll start with like a happy path, but at the same time, you're doing your black box, white box testing. You're coming up with all the fail-safe scenarios, all the things that could go wrthem.
Mm-hmm.
And it's all about a big part of it is collaborating very closely with the customer as well, because some of our most successful case studies actually leverage the customer as not just a client, but also a partner in the development process.
That is something so true in every state that we are seeing, is that frequent feedback loop and getting the customer, the end user input at the earliest stage has saved so much effort. Quality has improved, everything from the product life cycle point of view. So I'm hearing that even in embedded systems that is getting more prevalent. Is that what you're seeing?
Oh yeah, absolutely. And I think with a complex product, you've got to have your leverage your clients as partners in the development, especially in the testing process, and also in defining the product requirements and helping to iteratively test the product. One of the things I talk about in MedAgility is that many companies who are dealing with new technology and innovation, trying to get off the ground, instead of developing this hard, inflexible roadmap over the next 18 months to 2 years, it's more important to come up with a vision for your company or your organization or your product, and to evaluate new opportunities or new customers against that vision. And so, in other words, some of our most successful case studies, they had to make strategic decisions about which customers they were going to take on and which customers they were not going to take on, because they wanted customers that were going to work with them as a partner and help get this new innovative product out the door. Mm-hmm. If they had customers who were trying to be very difficult with them and say, or very strict, I should say, and say, okay, this product has to be perfect right out the door, and we want this, this, and this, and this. Our best case studies just basically let those clients go and focused only on those clients that were willing to work with them and help them accomplish their vision for their company and their product. And that's the kind of hard decisions you have to make, but it's proven to be very successful. That's why some of our case studies managed to become number one in their market.
So I think that's an interesting aspect of which customers to work with, and what basically that means you are building a team of the cross-sectional team, right from the developers, marketing, all the way to the customer. Extended agile concept. Yeah.
Your clients are going to be your biggest proponents. They're going to, if they're happy, they're going to brag about you. They're going to actually essentially be like another marketing department. And they're going to be happy because you've integrated them into your team. They're helping to define the product all the way from the beginning and to the end, where they're helping you actually test it and roll it out.
Yeah, I was going to say what I've seen is that this mode, though, of having hardware, firmware, and software being developed at the same time, there are particular challenges when you're bringing a new product to market. But then once the hardware and the firmware is out, you kind of move into almost like a pure software development cycle of improving, meaning the firmware may not need to be updated for a very long time, and yet the client applications that link to that system can be updated every 2 weeks. Maybe it's a mobile app. It's changing all the time. So I just wanted to sort of bring out at least that difference that I've seen, where there's a big difference about what you do when you first bring out a product and then how the product evolves once the first version is out in the market.
Yeah, certainly I'd say that's true. And one of the strategies embedded systems organizations use is they leverage their software team as sort of an early strike force. So if there's ever a problem out in the field that they find within a device or a product, it's much quicker and easier and more cost effective to solve that problem with a software solution than it is with a firmware or a hardware solution. And so they try to design the product in such a way as to try and say, well, maybe we can fix this with a quick software update. And that's what you want to do. And that's why, of course, Boeing is maybe not the best example, but they did try and solve their problem with software updates initially. And that is the best approach, because obviously if you're trying to fix it with a hardware solution or a firmware solution, which in some cases you may be able to, you don't want to try and do that because it's going to be harder to roll out. It's going to take longer. There's going to be a longer testing cycle. The software teams serve as an early strike force, and the most successful embedded systems organizations use them that way.
Interesting.
Yeah, makes sense.
So from your experience, especially in this embedded systems, where have you seen the agile transformations fail, and what was the root cause around that? Was it the way it was launched? What would you characterize as the agile failing?
Well, with an embedded system situation, the most common reasons they fail is they try to adopt Agile the same way across all these different teams and products. And that simply isn't possible. You know, hardware teams are not going to be able to adopt Agile in the same way that your software teams do. And so oftentimes the company doesn't understand Agile enough to be able to tell the difference. And of course, you may oftentimes, as they often do, they'll bring in an Agile consultant. And very few Agile consultants know a whole lot about embedded systems development and engineering. So most of them have worked in a software context. And so they're not really schooled in how to deal with this type of situation. And so that's probably one of the biggest reasons Agile transformations fail with embedded systems development. Now, and generally speaking, Agile transformations can fail for a variety of reasons, most commonly lack of executive support, or lack of executive engagement is one of the biggest reasons, or a lot of organizational resistance, or cultural issues, which are often based on fear. If people don't understand something very well, they're going to fear it. They're going to resist it. So a lot of times when organizations undergo an Agile transformation, they run people through this mill of Scrum Master training and say, okay, all right, now you're all Agile, let's get started. And that's just not really good enough. All your employees and your teams need to really understand why Agile is important and what it can do for the organization and what it can do for them as individuals and performers, because it can actually make you a better performer and a better technology professional. And there's just not enough training going on with these Agile transformations to help make people feel comfortable and get past this organizational resistance.
All you learn in those 2 days is Agile principles, but actual Agile execution, that's why the entry barrier is very low to get into Agile, but success barriers is very high, because understanding the principles and implementing and actually using them to its core, that takes basically a mindset change, and that takes time. That doesn't happen just by 2 days of training.
Right.
And as you were mentioning, from the commitment from the executive level or leadership, so that the couple of failures, they are ready to learn from it and then go to the next level. People are quite scared, or they are not sure whether if we fail, then what? And am I going to be the scapegoat?
Right.
So, unless that safe environment is created by the leadership, people will resist these kind of changes.
Yes, absolutely.
Steve, you had a question.
Yeah, I was going to say, an example of that we could look into is requirements. So typically when you go to product owner training, you come away understanding epics and user stories. And that's fine if, in certain environments, you can be getting feedback from your customers very quickly and then updating or writing new stories as you go along, even though you may have, you should have a roadmap and an overall plan, but you're able to be a lot more responsive. But I'm thinking here about when you have, for example, the firmware, and that the fact that is a much longer time frame to get the first version out. Probably the requirements have to be written very differently, and you have to have a better understanding of where the software may go in future in order to support all possible future features. So I just wondered, David, if you have any thoughts around that.
Yeah, I would say that requirements management is one of the biggest reasons that Agile transformations don't go too well. Many times when you undergo an agile transformation, all the focus is on the teams, the development teams, and the Scrum master, and having your stand-ups every day and doing all the rituals and all that. But in all the case studies I've conducted, I found that one of the biggest reasons for maybe not total failure of agile transformation, but lackluster results with agile transformations is poor requirements management and not changing the way requirements are managed. You know, a lot of times, typically in most organizations, when you're having a transformation effort, you know, jobs and roles change. And for example, in a waterfall environment, you're typically going to have a business analyst who's in charge of writing requirements. And that person will often have their role changed to a product owner when they undergo an agile transformation. The problem is they don't change the way they develop requirements. They still have that waterfall mindset. And so when you're writing requirements in a waterfall situation, what are you trying to do?
You need to go to the BRD and PRD and those kind of things right up front.
Yeah, the biggest the phrase I hear the most from BAs in that situation is, "Oh, I'm afraid I'm going to miss something. I'm afraid I'm going to leave something out." Well, in an agile environment, you're not really so afraid of that because you have another iteration to catch it, right?
Yeah.
But what's happening is these BAs are so used to working in a waterfall mode, they're used to brainstorming and trying to predict what requirements are really needed by the customer. And so they think of more and more requirements. Well, I think the customer needs this, and I think they need that. And they start adding more and more and more user stories without really working with the customer to sort of weed those out and develop them in a collaborative type fashion.
Right. I think they always forget the customer before they put their interpretation of customer.
Yeah, and so what happens is your backlog grows and grows and grows. You have all these requirements that are basically brainstorms from the business analyst, and it becomes impossible to prioritize. And then you end up developing features that are underutilized, and it costs the company a lot of money. And you start packing the releases fuller and fuller of stuff that you can barely deliver on time. And that's where the process starts to kind of break down, because you have these business analysts who are now called product owners, but they're not really changing the way they develop and manage their requirements. They're still in that waterfall mindset that they're afraid they're going to miss something, and they've got to constantly be predictive of what they think the client's going to need, because they're focused on this deadline. And the whole idea of Agile is that it's iterative development, that you can always constantly change and update and add as you go along.
So I think then really the question comes out as, I mean, that is exactly where the transformation has to happen, but maybe there is some different role, or their managers, or they're like a CPOs or somebody has to give that kind of a guidance. Or maybe an agile coach may have to step in there to give them the guidance as to, it's okay, you don't have to boil the ocean.
Right.
And what's your view on where that guidance could come from?
It probably has to come from training, I think. If you have someone inside the organization that has that knowledge, great. But oftentimes it requires somebody on the outside to help retrain this person to use a top-down approach to decomposing requirements, as opposed to a bottom-up approach. And it's a mindset change that usually requires some coursework and some training to do.
That's interesting approach. I mean, that's what we are seeing as to, if you look at how most of the requirements are, even the structure that we build is going from the product definition to the minimum viable product to the minimum marketable feature, and then to the stories. So it's like a peeling onion, and then finding the first successful path through that. But as you said, it is critical to get some training, get some hand-holding, get some learning. And first few cycles may not be successful, but whatever you learn from there, that's what is going to make a difference.
Right.
So going back to requirements, I just want to mention something I've also seen, which is because typically the development of hardware takes even longer than anything else. So there's firmware that's running in some hardware, but the hardware itself takes a long time. one of the things I've seen is that the hardware is sometimes not designed based on what the user experience is going to be. It's more based on what technology is available. There's a new chipset, there's whatever. So it's very hardware based and limited usually not by the user experience that we want to offer to customers, but more by like literally down to the penny. There has to be a cost saving here and there and so on. And then in some rare instances, that hardware can't even fully support the features that get added iteratively later on. So that's maybe very specific to certain industries, but I just wondered how the hardware design fits into this, not just the firmware and other software.
Yeah, I would say that's a problem I've seen quite often as well. The hardware is often driven by manufacturing constraints, availability of components like chipsets and things like that. Chipsets that are no longer supported, you have to upgrade to the latest chipset, or maybe the company has purchased a million pieces of a certain chipset that they want to use up, and now this chipset won't support some of the features that the software teams want to create. So yeah, I've seen that problem quite a bit. It occurs quite often in this situation. How do you manage that? Well, it's in MedAgility, I talk about, I go into a long discussion about, when we talk about Agile, we hear a lot about interactions. And in MedAgility, I go into detail as to classify the different types of interactions, and at what point, when, where, and how all these different teams, these different development tracks who are essentially developing different products, how they collaborate together, how they communicate together, and how they plan the systems release together in such a way as to make sure that these things don't happen as often. There's always going to be tension there. There's so many moving parts. These sorts of situations are probably always going to come up and happen, but by using some of the techniques I talk about in the book, it can help alleviate how often these things occur. So that, we have a chipset that's going to support this set of features for this amount of time, and we've got to make sure that when we plan our next release that we're going to use the newest chipset next year or something like that. So it's all about communication and collaboration internally, just like we talked about externally with the client. But having these planning sessions across teams is really important.
So we also see there is some trends about the hardware that is there that was not designed to support certain things that can actually do things that initially when it was deployed is asked to do something different. So how does that manifest itself, and how is that been successfully done, or have you seen that kind of a trend or use cases where the old hardware is doing new things?
Yeah, I mean, there's always different ways to. I've seen similar things come up, and you want to try and develop a mitigation strategy, or maybe it's not a software solution. Maybe the firmware team can create a solution that can help this chipset support what the software wants to do. A lot of times the firmware, the biggest constraint the firmware developers have, especially on small IoT type devices, is memory space. And so they have to design their code in such a way as to be very, very efficient. And a lot of times, if there's a new feature needed or something else we need to do from a software perspective, then the firmware teams can try and go back to the drawing board and squeeze a little blood out of the turnip, so to speak.
Yeah.
And they've been successful at doing that in many of the examples I've seen. At first you might think, oh, there's no way we're going to get any more CPU utilization or space or memory out of this chipset. But if necessity is the mother of invention, as they say, and a lot of times the firmware teams are able to make that kind of thing happen. So they're the glue that the point here is that the firmware teams often serve as the glue and the interface between the hardware teams and the software teams in an embedded system situation. And so they're often the go-to people for solving these kinds of problems.
Interesting. And so they are the liaison between the two entities, I guess.
That's right.
I'm quite excited about the kinds of things you are mentioning in your book. So I'll definitely go into details of your books, and I think many of our listeners would also like to know. So if you want to tell us how they can find it, and if they need to get in touch with you, what would be the best way for them to get in touch with you?
Sure. Well, you can type in Metagility on Google, and you'll see all sorts of things light up. The book Metagility is available everywhere books are sold. It's on Amazon, and it's on Barnes and Noble. I think it's on Red Shelf and just about everywhere.
Okay.
And you can, if they want to reach out to me, they can go to first. You can take a look at agileworks.com, agile-worx.com. And take a look at some of our workshops that we have coming up. And also, and of course, those workshops are scheduled for mostly in the fall, fortunately. So we had one scheduled for early May. We pushed that one back to the latter part of May in Denver. But the rest of them are scheduled, I think, starting in September. But you can take a look at those, and also reach out to me personally. You can email me at david@agileworks.com. Again, that's agile-worx.com.
Okay.
And I'll be happy to chat or answer any questions. I love hearing from people, so that's the best way to get in touch with me.
Well, this was really great, David. Really appreciate your time. A lot of people are working in this space and having struggles, so we'll definitely put a link to the book and the other resources you mentioned in the show notes. So again, thank you very much.
Thank you.
Bye. Thank you.